Hello, and welcome to an episode of ES Repair. I'm your host, Mr. Fix-It. In this video, you'll learn how the Junction Field-Effect Transistor is used and different ways that you can test them. So let's get started. Here, we're looking at Junction Field-Effect Transistors, also known as JFET. Now, there are two kinds. You have the N channel and the P channel. The current will flow from the drain to the source and from the source to the drain. They're not real picky about which direction the current flows. Now, they can be used from amplifications, mostly like preamplifiers, and they are also used to generate high frequencies. Now, the way these work is as you apply a small current, I mean very, very small, you can control what current flows through the transistor. Now, these are not like bipolar transistors, because bipolar transistors rely on current, whereas field effect transistors rely on voltage. They have like the advantages over the current controlled bipolars, and the reason for this is because the input, which is the gate, the resistance between the gate and the channel is so high that there's no effect whatsoever by connecting these directly to the output of an integrated circuit, such as the 555 or a 4017. You know, any integrated circuit can connect directly to one of these without any effect. Now, what happens is the resistance can be so high it acts almost like a diode. Now, if you've ever tested a diode, you can see that when you apply the voltage to the diode, it will show you how much voltage it requires. Well, the resistance is so high on these things that it acts kind of like a diode. Now, they can be damaged just like a bipolar. But next, let me show you how these things work. Here is a basic setup to test your JFET. Now, I'm going to be using an ammeter or an amp meter. Now, if you look to the left, you'll see how I got my batteries connected. It does create 18 volts, but I'm going to use the center, as you see there, where the 0 between the two batteries. This will create my common ground or a neutral ground. This will allow me to generate a negative 9 volts, as you can see in the picture. The P channels connect the exact same way. It's just the difference is that the gate function is the opposite of the N channel, which I'm going to demonstrate. But this is a quick look at the setup. You get the 300 ohm, that's my current load. The 1 kilo ohm will limit the current to the gate. So let's get started. Here I have a demonstration set up to show how these transistors work. And what we're going to do is I've got the 330 ohm resistor. This is going to be my load current. I've got the 1K, which I haven't unhooked because I'm going to show you how sensitive these transistors are. First thing you want to do is, before you test your transistor, you want to get all the pins on the transistor touching each other, just like I'm doing here in this one row. These transistors are voltage controlled, and they do store a charge, so to speak. unlike bipolar transistors, they depend on current. The more current you apply to the base, the more current you can control between the collector and the emitter. These are different. These are voltage controlled. The more voltage that you give it, the more current you can control with it. But these are voltage dependent. Now here I've got the charge removed. I'm going to insert it into my board. You want to be sure not to touch any of the pins, because these transistors are sensitive. Let me insert it into the board. Now the way this is going to work, I've got my two 9-volt batteries, and as you've seen in my diagram, to give you I wanted to give you a clue how this was all going to connect and work. Now I can connect my power supply. Turn my voltmeter on. This meter here will measure the current, and this meter will measure the voltage at the gate. Now, to give you an idea about the power supply, I do have this lead here connected to the neutral or the ground, which is this one right here. As you can see, there's 0 volts, so I'm on the ground. Now if I test this up here, you can see I get 9 volts, positive 9 volts. Now if I touch the yellow one down here at the bottom, you'll notice it says negative 9 volts. Now these voltages are in respect to this ground. And by seeing the diagram, you'll see how I managed to get my positive 9 volts and negative 9 volts. This resistor here, which is a variable resistor, will control the voltage. If it goes this way, the gate will become more positive. If it goes this way, it'll become more negative. Now, depletion refers to the state of the transistor. Think of it as an open switch. Either the switch is normally open, which means that you have to press the button in order for it to conduct electricity, or normally closed switches means that you have to push the button to disconnect the power, or interrupt the current going through the switch. Well, these are considered normally closed transistors. Here, I'll demonstrate. Let me turn my meter to milliamps. Now, notice I have no connection to my base. This is base to my gate. What this does is to demonstrate that the transistor is normally closed, meaning that it's going to normally conduct current without the gate. Now, in order to turn off this transistor, it must have a negative voltage. Now, for the P channels, it's the opposite. To turn them off, you have to give it a positive voltage. Now, the P channels will connect the same way as this does. The only difference is the voltage. Here, this is an N channel, which means it requires a negative voltage to turn them off. P channels require a positive voltage to turn them off. Now, notice I've got positive 9 here, negative 9 here. Okay, so now that's ready. Now, because the transistor is still conducting, watch what happens when I touch the gate. Now, I'm just going to touch the gate with my finger. Now, watch what happens. Did you notice how it went dead? Just from touching it with my finger, the transistor was turned off. This is how sensitive these transistors are. Now watch what happens as the negative charge dissipates in the transistor. Notice how the current is slowly increasing. This is because the negative charge is dissipating in the gate. And it'll keep going until the charge disappears. As you see here. Now, watch again. All I'm doing is just touching the gate with my finger, and I can turn the transistor off. Now, let me connect my 1K resistor . Now, the way these work, there's no polarity to these, actually. I can have the current go through the drain to the source, or from the source to the drain. These aren't that real picky. The gate can either have a positive voltage or a negative voltage, so it can work either way. Now, notice here, let me get my adapter connected. Notice here, I'm going to hook this positive to this positive lead for the base. Now, notice here it says that I have negative 0.66 volts. Just under 1 volt. Here, it went from 7 milliamps down to 4 milliamps. So you can see how the negative voltage affects these transistors. Now, let me change it some more. And watch the voltage as I do this. Now I can go all the way up to 15 here. That'll be close enough. Now look, I've got 0.7 volts at the base. This is positive because you notice there's no negative symbol. Now I'm pulling 15 milliamps. Now you can see how sensitive these transistors are. Now what's going to happen here now, let me turn it the other direction. See how it keeps going up? Okay, well, let's make it more negative. Now notice how the voltage drops, the current through the transistor also drops. This is how they're voltage dependent. Everything is controlled by voltage at the gate. Now, I'm going to get this down to 0. And there you go. I've completely turned off the gate. And I'm only using negative 2.68 volts. And now the transistor's turned off. Now, if I was to remove the negative charge, notice the transistor turned back on. Now, if I apply the negative charge, these can be used as switches, amplifiers. This is how sensitive these transistors are. Just like that, just by removing the negative voltage. Well, this is how a demonstration of how these things work. Now, let's move on to how to test these transistors to see if they're good. Now, here is a very simple test you can do. This meter here has diode checking capabilities, and this is what you're going to need. Now, you can test the resistance, but you won't be able to get a very accurate reading because the way these transistors are set up. But first, let's check the ohms. I'm going to show you what you could check. Here I have my ohm meter turned on. It's over the limit. Now I'm going to take my test leads, test them to show you the resistance in the meter, that the meter is working. Next thing we're going to do is, according to the data sheet, this pin here, which is my center pin, is the source pin. This pin on the end is the drain pin. And this is the gate pin. Now, you can use the ohm meter to test between the drain and the source, like this. Now, you will receive, some resistance, not much. It's rather low resistance. This one here is just less than 200 ohms. Now, to show you that these can work in either direction, the resistance will vary slightly. Here, let me switch the polarities of the ohm meter. Oop, there we go. So as you can see, they vary just slightly. Now that is one indication that it's working. Another indication is turn the ohm meter or your digital meter to diode checking. This gives you enough voltage to test the gate. This is what we're going to do, is test the gate. Now if you put your positive lead to the gate, your negative lead to the drain, you'll notice that it takes 0.724 volts. Okay, that's an indication that it works. Same thing if you want to check your source. You should also get around 0.7 volts. So far it checks out. Now, let's check in reverse polarity. Put my negative on the gate, put my positive on the drain. You should get a very high resistance, just like I'm showing here. It's over the limit. Okay, let's check the source pin. Again, you should get an over the limit or no measurement whatsoever. This is a good indication that this transistor is functioning. Now, two things to keep in mind. If you get the same thing, which is OL, regardless of how it's tested, like this. Now see, this shows it works, but let's assume that it don't. Now if you get this resistance, no resistance whatsoever, and either polarity that you're checking, this indicates that the gate is open, which means that the transistor is bad. Now if you're getting something like this, and either polarity checking the gate, this would mean that the transistor is shorted, and in other words, it's faulty. Well, this concludes this video. We covered junction field-effect transistors. I showed how they're used, how they work, and different ways you can test them. I hope this video was informative. Please subscribe to our channel if you wish to keep updated with our activity and future uploads. And be sure to vote on our videos to let everyone know if you liked it or disliked it. And if you have any comments, please feel free to post them and send us questions if you have any. I'm your host, Mr. Fix-It. Thank you for watching.